Hello and welcome back. My name is Michael Fudge and this is lesson 17 in our Learn to Program in Java series. In this lesson, we'll cover file input and output. On the agenda for lesson 17, first we'll talk about the basics of file I/O, that is, how do you read and write to data files. Talk about the two formats in which you can read and write to files: text files, which are human readable data, and binary files, which are only machine readable. Then we'll do some examples of some basic text file I/O, and we'll do some examples of binary file I/O, specifically focusing on serializing the objects that we've made already. So let's talk about the basics of text file I/O in Java. My argument is if you can do console I/O, which we've been doing all up until this point, you should have no problem implementing text file I/O. It's pretty much the same thing. As a matter of fact, when you think of system.in, which we usually think of that as the keyboard, but think of that as an input of text. And then system out, think of that as an output of text, and really you have what's going on. Now, rather than us reading from system in and system out, instead we're going to use the class file. And in Java, the class file is a representation of a physical file on disk. As a matter of fact, when you construct an object of class file, you usually give it a string that represents the file that you want to use. To mimic the print, println, and printf methods that we're used to, we will use the printWriter class. PrintWriter is used to output to a file the same way you write to system out, you use PrintWriter. And for input, we'll continue to use scanner, which tends to be the most flexible class for doing input from a text file. And this will work the exact same way as you know scanner already. Instead of using system in, we'll use an object of type file class instead when we create our scanner class, or an object of our type scanner. Okay, let's jump into a demo. In this first demo, we'll do something really boring, like create a file, write some data to it, and then open the file back up and read the data back out. Nothing earth-shattering, but it'll at least give you an idea on how file I/O works so that you can kind of build your own examples from there. Okay, here I am in my NetBeans IDE, and I've created a new project called Basic File I/O, and I have one class called basicfileio.java. And I'm going to start writing to a file, and then after I write to the file, I will read what I wrote back out. Then I will show you where the file is on disk, and I will open it up and show you that it really is a text file and it contains human readable text in it. Again, the difference between a text file and a binary file is the operating system treats a text file as text, which is of course human readable, and a binary file is binary, that is just a series of ones and zeros, and it's no guarantee that it will be human readable. Let's start by making an object of type file, and let's call this test.text. So the first line that we've added here comes from the package Java I/O, and it's a file class, and I call the variable file because I'm uncreative, and I'm going to make a new object of type file, and it needs one argument, which is the name of the file. There it is, test text. Now, file is a substitute for system in or system out that we can use with PrintWriter and scanner. For example, let's write to the file, name and age to the file. So I need a PrintWriter to do that. I'm going to call it output, new PrintWriter. Where is this PrintWriter going to write? It's going to write not to system out, it's going to write to file. File is in essence a reference to test.text. Need to include that package. Okay, output.println Mike Fudge, output.println 42. One important thing to note when you are using file I/O is that you have to remember to close the handle to the file. This is important so that it releases the file for use by other programs in the operating system. Something different than when you use standard input and output, that is the keyboard and the screen. Now if you notice, I'm getting an error here, and that's because I need to use a try. This may throw an exception, so I need to catch that exception. And I can just follow the advice here if I want, or I could do the right thing and surround it with a try catch. This is why we introduced the exceptions unit before we introduced the file IO unit. You need to know something about exceptions before you can correctly handle and address file IO issues in Java. It raises an IO exception, so I want to catch that exception. And what should I do when I catch this exception? Probably do something like this. Let's print out a message. The specific error I'm going to print, I'm going to just say error, and then %s, and I'm going to just send in EX. And when I send in the object EX of type IO exception, it will convert this to a string because of this format specifier. And so it'll take the exception and then just blurt it out as a string, but I'll see it on the console. So if some error is to be raised from this operation, it will show it out. Let me reformat this code so it looks a little better. Okay. So this, in essence, will write to a file. And at this point, I can run the program. It's not going to do anything exciting except write to the file. Now, you might be wondering, where's this file? So let's go find it. Well, the actual location of this file will vary a little bit based on your operating system. So here's the best way to find it. It's going to be in the same location as your project. So if I right-click on here and go to Properties in my NetBeans IDE, you'll see it says Project Folder. This is the location of that file because I didn't specify any other path. So I'm going to copy that project folder, and then I'm going to just explore the operating system file system, and I'm just going to drop that in there with a paste, and then there's test. See that? And my text file, it's human readable, and the first line, print line, Mike Fudge, that's what was printed. Second print line, 42, that's what was printed. So it did exactly what we expected. Let's write a program to read that file. Or let's continue our existing program, I should say, to read that file and then print the data to the console just so we know that we're correctly reading files again. So to read a file, we need the scanner class. And this is going to look similar. Normally here we'd say system in, right? Well, we don't want to read from the keyboard. We want to read from that file. So I'm going to put in that file. And now I can say string name is input.nextLine. Looks very familiar, doesn't it? Except I'm not getting input from the keyboard anymore. I'm getting input from this file. Since I know this is actually an integer, I could say next int here. And then I could say int age if I really want to. And then I can print them out. Name, %s, age, %d, comma, name, age. Now I'm getting an error here. So once again, for this error, I need to use my try catch. Now what kind of error can be raised here? You need to worry about catching the file not found exception. Because again, what if I try to read from this and it's not there? That's going to throw an exception. I need to handle that exception. So I'm just going to repeat my error message. I'm going to be rather uncreative. I could say something like, please choose a different file or something along those lines, but I'm just going to merely handle the error with grace. Now one important thing is if I didn't want to do a try catch in here, I could force this method to throw those exceptions. I could say public static void main throws file not found exception, IO exception up here, and then that would address the issue as well. But I think I'll catch them inside this method and do something with them. Okay, I think I've got it, and I think this should do what we expect. It should print out my name and age. Name Mike Fudge, age 42. It's important to note that it is it is reading these from the file. And just to prove to you that it is reading them from the file, I'm going to go back here to the file, Mike Fudge 42, right? I'm going to go into this code here, which this code here writes to the file, and this code here reads from the file. Right, this reads from the file, that writes to the file. I'm going to take this and just comment it all out. So now my program will only read from the file. It doesn't write to the file. So let me run it. It says Mike Fudge, age 42. Now let me go to my file, and let's change this around. There we go. Save my file. And when I run it this time, it better not say Mike Fudge, age 42. It better say Kelly Jones, age 46. And it does. Ta-da! See that? So as you can see, reading and writing to a file is not that much different than reading and writing to and from the console. As a matter of fact, I could easily take a lot of the programs that I have written in the previous units and modify them to no longer accept input from system.in, but accept input from a carefully crafted text file. So that's really kind of the basics of text file I/O. As you can see, text file I/O is really no different than the I/O you already know. When we get into object serialization in a bit, you're going to see that this works a little bit differently, and that's because you're taking what you have in memory as an object and then writing it as binary to disk. There's lots of ways that you can do binary file I/O, and I think what I need to emphasize here is the most common thing that we're looking to accomplish with writing to a file and reading from a file is to be able to take our objects that only exist in memory and persist them. That is, maybe you have an object that holds your application settings. You know, it's an object of class settings, and it holds all sorts of different variables that control how your application works. And what you want to do is you want to have a way that those settings can be saved to a file so that the next time the program is run, a user doesn't have to configure how they want the application to behave, right? That's a great example of object serialization. So object serialization is just a process we use to convert an in-memory object into a series of bytes so they can be written to disk. And so we have two concepts. We have object to disk, we call that serialization, and we have taking it off of the disk and putting it into the object. That's called deserialization. The way this works is if you want your object to be capable to be serialized, in other words, if you want your object to be serializable, all you need to do is implement the serializable interface, and then your object will have this capability. Now that you've got a serializable object, how do you actually go about reading or writing that object to file? So once again, it's going to start with the file class, and then from there we're either going to make a file input stream if we want to read it, or a file output stream if we want to write it. And the input and output streams are telling Java to treat that data file like bytes and not like text. From there, we will use the object input stream or object output stream to actually do the serialization or deserialization. That is, taking the object and putting it in the file, or taking it out of the file and putting it back in the object. Again, so you need 5 things. To read from a file, you need an object of the file class, then you're going to need the file input stream, and then the object input stream, and ultimately you'll be able to read that serializable class. To work the other way, you're going to need obviously a file, and then the file output stream and object output stream to write that object to the file. Okay, let's get into a really quick demo. Okay folks, here I am in my NetBeans IDE with our next example, and in this example I have 2 Java classes I made. One is called Student Java, and you've seen this example hundreds of times before already in this class. The only difference between this implementation of student and other implementations of students is I added implements serializable and imported a package Java IO serializable. And this tells Java that I would like to take this student object and read to and write from a file with it. Okay, I would like to serialize it. And then here is my sample program, and in my sample program all I've done so far is I've made a reference file to students.txt, which does not exist at this point. And I have an array list, a dynamic collection of type student, and I'm calling it students. What a great name. And then I add 3 students. So if I were to run this program, it's not going to do much of anything at this point. But if I run it and then put a breakpoint on line 16, you would see that I have this collection students, and it's got 3 actual objects of type student in it. So maybe the first thing I want to do is maybe I want to write all 3 of these students, that is, write the entire collection to a file. Let's see if we can do that first. So I would like to serialize the collection of students. And I spelled serialize wrong, but that's going to happen. So first thing I'm going to need is a file output stream. And I'm going to call it, because I'm very uncreative, faux. That's going to be a new file output stream with my file. And of course I've got my red line here because I need to include the package, and now I still have a red line. It says unsupported exception, file not found exception, must be caught. Or I have to decide to not catch it and then just throw it up here in my main method. For example, I could just say it was file not found exception, right? I could just come up here and say, well, this, I'm not going to catch it here, but this is going to throw a file not found exception. Rather lazy yet convenient. So if I decide to not catch the exception when the potential file not found exception when this occurs, then I need to make sure that the method that this is contained within will graciously throw that exception for someone else to consume. I think I'll take that option rather than wrapping it in a try catch. Now I need an object output stream. I'm going to call this output, and that's going to be a new object output stream, and it's going to take not the file but the file output stream. This is always the pattern. The file output stream takes the file, the object output stream takes the file output stream as its argument. And you can see that this is also complaining about throwing an exception. This throws an IO exception. So again, rather than surround this with a try catch, I'll just come up here and say, well, it throws a file not found exception, and also maybe it'll throw an IO exception. Okay, now how am I going to write these? Well, it's actually quite easy. I'm going to say for each student, I'm going to call it S, in my collection of students. How about we do this? Output dot write object. Which object do I want to write? S. And of course, you always want to clean up after yourself. It's what our parents always told us. Clean up after yourself. It's what I'm telling you now. When you use file IO in Java, clean up after yourself. What does that mean? You want to close all references to the actual file itself, right? So I need to make sure that I output dot close. So I need to make sure I type output dot close, and of course file output close. There we go. So this program in essence will make this collection, and then this code here from line 19 to 26 will serialize those 3 objects. Let's run it. Nothing exciting happens, but now if I go here to my source package There's where my project folder is. If I open this up, you'll see there's a student's file right there. If I open it up, this is now a binary file. You see when I open it up inside a text editor, I don't see anything that makes any sense to me. Okay, I might get lucky and see Dave and Bill in there and Tom, right? There's little hints of things, but this is certainly not human readable, nor is it designed to be. What it's designed to do is be a very quick and easy way that Java can write to and read from that file to and from into objects. So yes, I just serialized it. Now let me deserialize it. Deserialize the file back into the collection. Okay, to do this, I'm going to need a file input stream. I'm going to call this FI. That's going to be a new file input stream using our file. Then we're going to say object input stream input new object input stream using my file input. Okay, and there we have it. Now I need to read into my collection, right? So I guess rather than cheating and using the same collection, let me do this. Come down here, and I'm going to call this students 2. So now you know it's a completely different collection. And let's do this. While true, and let's say student S is student input dot read object. When you read an object, it returns an object back. I need to cast that object or treat the object that I read as a student before I assign it to an object of type student. You need to explicitly cast the object. And then let's add it to the collection, students 2.add s. Now, what's interesting about reading from an object is you might say, well, how do I know when I'm done, right? Well, when you can no longer read from the object input stream, it throws a end of file exception. So I need to catch that. And you see it's not throwing an error because I'm not catching it, but this will loop, and then actually this goes back to the difference between a user generated exception and a program generated exception. This is going to be a program generated exception. So I need to catch this. So I'm going to do this. So this is really the true pattern you need when you want to read an object input stream. That is, if you want to deserialize an object, you need to do this pattern. Try this, and at some point you are going to catch an end of file exception. And when you do, you're done. I know it looks kind of goofy, but that's how it works. So again, it's going to loop, and it's going to keep reading in the object and putting it in S, then adding it, reading in the object, putting it into S, adding it, and then as soon as it hits an exception that says there's nothing more to read, that's end of file. So it'll catch that exception, and then it'll exit out of the loop, because obviously in the try catch block, when the exception is thrown, it's going to stop running this code and start running this code. So it's really kind of an inelegant way to stop looping. There is no end of file condition in the object input stream. There's just an exception that gets thrown. You'll notice also I'm still getting an error here because I need to catch a class not found exception. What I'm going to do is I'm just going to do that up here. What you're saying when you do this, by the way, is you're pretty much saying these are the I give up throws, especially in the main method. You're saying, you know, if anything happens down here, you know, just let these exceptions fly, and then you'll see them in the console. Under normal circumstances, if this was some kind of method in a class, right, we might want to throw these so that they go up to the caller, and then the caller can address them with a try catch. But it certainly doesn't make a lot of sense to do this in the main method, other than the fact that your teacher is lazy. Okay, so now when I get to this point in line 42, I should have a collection of students too that has the 3 names in it. So let's print them out. So this is, again, a little goofy, but again, this doesn't really make a lot of sense, but I just wanted to prove to you that I'm not just pulling the wool over your eyes and printing the same thing we already had. I actually took this, wrote it to a file, read it from a file, and then put it back into memory in a completely different object, and then I'm going to print out that object. Okay, so now this should do something rather uneventful. If it works, it's going to just print out Tom, Dave, and Bill. Do you see that? Tom, Dave, and Bill. But really what happened was I had Tom, Dave, and Bill in memory under students. Then down here, I serialized Tom, Dave, and Bill into the file students.txt. Then I deserialized Tom, Dave, and Bill from students.txt into another array list, students2. Then I printed out students2. And if you really don't believe me, I'm sure many of you do believe me, but if you don't believe me and I debug this, when I hit this breakpoint, you'll see I have 2 collections in memory. Students, this is my original one. See, there's Bill 2.0, and here's students2. And that one also has Bill 2.0. And how did it get in there? I read it from this file. And there you have it. That's file serialization and deserialization. What do you need to know and what do you need to remember? What you need to remember is that to write to a file, to write an object to a file, you need the file output stream and the object output stream. And the object output stream takes as an argument the file output stream. And you just call the write object method to put that object in the file. When you're reading, it works kind of in reverse, but you say input read object, and then you have to remember to cast that object to the target type. So once again, in order to correctly read from a file, you have to know what's expected, right? I expect this file to contain a bunch of students, and so that's how I know to cast it as a student. And then lastly, when you can read no more from the file, it will throw an EOF exception, and you have to catch that exception. Otherwise, your program will crash, right? If I do not catch this exception, I will get an error when it cannot read any more students out of the file, and I probably don't want that. I want the program to continue. Well, this concludes our lesson on Java file programming. We learned how to read and write to text files, and we learned how to serialize objects. Thank you very much for watching, and I'll catch up with you again next time. In the meantime, I welcome your questions, comments, and feedback on YouTube. Thanks a lot, and bye now.